Today's lesson is 6.4, using inverse functions. To find an inverse function, we're going to take the domain and range of a function and switch them. This is actually a really simple process, so we're just going to start with an example. If y equals 2x plus 1, its domain is x, because x stands for domain, and the range is y, because y stands for range, and what we're going to do is we're going to flip-flop them. So where x was is y, and where y was is x. This is immediately the inverse function. But I have to go ahead and get y by itself so that it's in function form. So I'm going to subtract 1, not x. I'm going to subtract 1 from both sides, so I have x minus 1 equals 2y. Then I'm going to divide both sides by 2. So I have x minus 1 over 2 equals y. This is the inverse function to what I started with up here. And it's just that simple. We just take x, y, and switch it, and then we get y by itself, and we're good. So let me show you another example. Y equals 1/3 x. So changing the x and the y, now x equals 1/3 y. I need to get y by itself, so I'm going to multiply both sides by 3. So I have 3x equals y, and now these two functions are inverses. That's it. That's all there is to solving an inverse function. Okay? However, if you have two functions that are suspected to be inverses, we can verify or prove that they are inverses by doing the composition like we did in 6.3. So we can do f of g of x equals g of f of x, and this is not very hard either. Let me show you how to do this. The example I have for you is f of x is x plus 4, and g of x is x minus 4. So for f of g of x, I'm going to take the g function and plug it into f. So I'm going to take this function and I'm going to plug it into this equation. So that would be x minus 4 plus 4. X minus 4 plus 4. The 4's are going to cancel, and so my answer is x. Now look what happens when I go the other direction. G of f of x. This time I'm going to take the f function and plug it into g. So I'm going to take x plus 4 and plug it into the x of the g function. So that's going to be x plus 4 minus 4. And x plus 4 minus 4, the 4's are going to cancel, and I'm left with x. See how these are the same answer? When you get the same answer for f of g of x and g of f of x, that means they are inverses of each other. Because when we learned this in 6.3, our f of g of x and our g of f of x were not the same, if you recall the gift certificate and the discount problem where we got different answers. Now this problem was pretty straightforward, so let me show you another one that might not seem quite as straightforward. So let's do f of g of x first. So I'm going to take g and plug it into f. So I'm going to take this, the fifth root of x, and I'm going to plug it in right here. So that's the fifth root of x to the fifth power, because I'm replacing the x, but the fifth part is still there. So what happens if I have the fifth root of x to the fifth power? Well, the fifth root and the fifth power cancel each other out, and you're left with x. Now if I go the other direction with g of f of x, I'm going to take the f function and plug it into g. So I'm going to take x to the fifth, and I'm going to put it in where this x is on my g function, but it still has the fifth root part. And we have the exact same situation. The fifth root of the fifth power, they cancel each other out, and I get x. And so these are inverse functions. And that's how you verify an inverse. It's not too bad. Okay, so now the magic trick that hopefully I worked for you in class. Here's what we did. I told you to pick a number from 1 through 10. I told you to add 3, so that's adding 3, multiply by 2, and divide by 4. And then I used the inverse to figure out what your number was. So in this case, 2x plus 6 over 4 equals y would have been the equation I asked you to solve. So if I take this and I switch the y with the x and resolve it for y, then that's how I figured out your answer. So this equation ended up to be 4x minus 6 divided by 2. So when you told me maybe your number was 2. So if you plugged 2 in to this equation over here, then you had 2 plus 3 is 5, 5 times 2 is 10, 10 divided by 4 would have been 2.5. So I took your 2.5 and plugged it into this equation. And I said 4 times 2.5 is 10, 10 minus 6 is 4, and 4 divided by 2 is 2. So from using your output, I used the inverse function to determine what your input had been. And that's how I did my magic trick. It was really an inverse the whole time. Okay, so your assignment is page 102, 1 through 12. So 1 through 12, all. Have fun.